Table saws cause over 30,000 injuries each year in the United States alone. This video is about how to prevent table saw kickback. There's no video, there's no guru, there's not anything or anyone that can tell you or show you or absolutely positively say that when you're using a table saw you will never experience kickback. It's just something that can happen, but you can do everything in your power to prevent it from happening. I've heard many a times that a table saw is the most dangerous tool in the workshop. I don't look at it that way. There is a certain amount of risk to using a table saw, to using a circular saw, a reciprocating saw, to driving a car to the store. It's all about, are you willing to accept that amount of risk in order to do what it is that you want to do? And for me, a table saw is worth that amount of risk. This table saw right here has sent me to the emergency room. It was not the table saw's fault. I didn't run out, replace it with some fancy table saw. It was my fault. I'm going to explain to you what happened to me that day, and we're going to dig into how to prevent table saw kickback. This video may be for people who are thinking about buying a table saw, have just bought a table saw, and even someone who's been using a table saw like me for years. You may have forgotten things, you may have become lax, you may have become complacent, you may have become just too relaxed with using a table saw, and that's when the problems start. Hi everybody, I'm Jim Dierdorf and this is Detroit DIY. Let's dig into this. Before we discuss how to prevent table saw kickback, I first want to explain to you why kickback happens. There's actually two different types of kickback that can occur. One being bad, the other one being really bad. So let's take a close look at the first one. Kickback can occur in the table saw because the blade is rotating towards you. That's kind of the nemesis, that's the big issue, that's the reason why this happens in the first place. There is no other way to operate a table saw. You certainly wouldn't want the blade rotating away from you and trying to pull the wood out of your hands as you feed it through. The first type of kickback is when you're cutting a strip of wood similar to this, where you're cutting off a small piece off of a larger piece. And what can happen is if you lose control of this piece of wood, let's take this one out of the way for a minute and just pretend that we're cutting it off. When you get to this point right here, I have my blade raised up way higher than I normally would. When you get to this point right here where the wood just cuts, and if you're using your push stick and you're feeding it through and something happens and you lose control of this piece of material that you're cutting, the blade can potentially grab this and eject it out of the saw at a rapid rate. And depending on where you're standing, it could get you. That is the best case scenario, and believe me, the table saw will shoot this out like an arrow. Let's talk about the second type of kickback. I have this material on the incorrect side of the fence, but just to better show you, the second type of kickback happens when the material gets to this point right here in the saw blade, since the saw blade is rotating towards you. And what can happen is that if it binds on the blade, so the kerf of the cut binds on the blade and it grabs these teeth, and the saw blade starts to lift it up because that's the rotation that it's going. It lifts it up and it actually can kick it in and it gets on top of the blade. Once that happens, this piece is going to shoot out at a very rapid rate, and it is going to possibly hit you in the face, hit you in the chest, hit you in the stomach. Very, very worst case scenario is what happens is you've got your hands on it and you're feeding it in, and it leaves the saw so rapidly that your forward effort to push the board through, and all of a sudden it's gone, and your hand can go right into the blade. It's not necessarily that the material pulls your hand into the blade, it's the fact that you are pushing this material through and all of a sudden it's gone. And believe me guys, I've experienced table saw kickback I almost lost the end of this finger. They were able to sew it back on. It's a little different than it was, but it still works. I still have feeling, and I'm glad that I do. So understanding this type of kickback is key to preventing it from happening. So now that we understand how kickback occurs and the two types of kickback that there are, let's get into how we can prevent it. The number one way, in my opinion, to prevent kickback is to use a riving knife. That's what this is. The riving knife in my particular saw is adjustable. So I can lower this riving knife down for a non-through cut. So if I'm cutting a slot in something, I can lower this riving knife down and cut a slot through, and it will not interfere with my cut. When you set the riving knife in its highest position, it is set for a through cut. Now this is important for a couple of reasons. The biggest area of concern is this gap right here between the riving knife and the blade. That is the only chance this blade has to grab the material before it gets to the riving knife. Once it gets to the riving knife, it's going to hold it off of the carbide of the blade. So the kerf of the cut will be off of the blade. So as you can see, I can hold this piece tight to my riving knife, and I can spin the blade. And you can hear it touching it, but it's not trying to grab it. So if I hold it right here, it tries to grab it. It picks it up. Because the carbides on the blade actually stick out further than the blade itself. The other thing that we need to be cautious of with our blade versus our riving knife is that riving knives are different thicknesses. My particular riving knife is 90 thousandths thick, so it only actually works the way it's supposed to if I'm using a saw blade with carbides that are 90 thousandths thick. If I want to use a thicker blade, a 1/8 inch blade or whatever, I need to put in a riving knife of appropriate thickness so that the riving knife itself is as thick as the carbide tooth on the blade. This is the number one thing, guys. It's easy to remove, and if you're running a dado stack or you're doing something like that, you have to take this out. So it's simple to remove, it's simple to put in. It's adjustable. That's the thing that's very important. So it's not just adjustable up and down for different cuts. So if I slide it in like this, now it is set for a partial cut through a piece of wood, or halfway through the piece of wood, but not a full cut. It is also adjustable from side to side. The operator's manual of your saw will explain this to you, how to adjust this. So you want to make sure that this riving knife is lined up perfectly with your blade, not off to one side a little bit or off to the other side. If it is off to one side or the other side, you're going to feel it when you're cutting the wood. So if you feel it, if your wood gets to the riving knife and it becomes resistant to push, turn your saw off, guys. Turn it off. Go to your owner's manual, read how to adjust this. You'll feel the wood catch on it when you're pushing it through. That means it's incorrectly adjusted, and that can be bad news, because if it's leaning towards you, the blade can be exposed to the wood as it's going through the fence. That's not a good thing. That will provide the blade the opportunity to grab the wood. The whole idea of this riving knife is to prevent the blade from being able to grab the wood. Let's move on to the next step. Let's say you are going to do some woodworking and you've seen on, YouTube or whatever, a zero clearance throat plate. This is not a zero clearance throat plate. This is for my dado set, but it is the only homemade throat plate that I have. I do not do a ton of woodworking, so I do not have a zero clearance throat plate for this blade or any single blade for my saw. When you are running a custom made or a homemade zero clearance throat plate, the riving knife cannot be used. Because this is set up for a dado set, I do not need a splitter or a riving knife. So a splitter would be an insert right in this area that would take the place of the riving knife. A splitter is not as safe as a riving knife, but it is better than nothing. So if you're going to make a zero clearance throat plate for doing woodworking, they sell splitters online. You can get them. Some are plastic. You can make some out of wood, different thicknesses. Just make sure that you make that splitter the exact thickness of the carbide of the saw blade that you're using. Secondly, you can install all this stuff that came with your table saw. I do not use it. I have it all. It hangs on the side of my saw. I do not use it. It's not, in my opinion, going to prevent kickback any more than this riving knife alone is going to. I'll explain that to you and why I feel that way. When you're cutting a piece of wood, this area right here is the danger zone. When the kerf of the cut reaches the back of this blade but has not yet reached the riving knife, if things are going to go wrong, typically they are going to go wrong right here. So here's the problem I have with this. These are anti-kickback pawls, but they're almost beyond the back of the riving knife. If I was going to have an issue with kickback, it would have already occurred before the board even got to these. So to me, this is just something that the saw companies put on there so that you can feel better. It is not actually going to help you one bit. This is the area of concern right here. These are beyond it. If these were somehow mounted here, more forward, I would say that this would be a fantastic way to help prevent kickback. But where they are actually mounted, it makes no sense. Also, in my opinion, the blade guard itself is actually more of a feel-good device than a purposeful device. I don't like it. I've never used it. I've never used this, and I've never used this. Even after my table saw accident, these never went back on my saw. The problem was, like I said, I lost control of the piece of wood. As I was cutting it, I let go with one hand, and I had it with the other hand to reach for my push stick, which was sitting right over here on this side of the saw, and that is when my kickback occurred. And in doing so, I've changed some things in the way that I use the saw. I like to be able to see what this blade is doing and where it's cutting. And we're going to get into that and why right now. There's two reasons why I like to be able to see my saw blade while it's cutting through the wood. One is the accuracy of the cut. I like to have good visibility of my fence, and I like to have good visibility of my blade, my marks on my wood, and what this blade is doing in conjunction with those marks. The second reason I like to see this blade is because sometimes I do extended periods of cutting, and the blade can become dull. I can become complacent and say, I'm just going to finish. I know this blade's dull. I'm going to finish. Well, what happens when a blade gets dull and you're cutting wood is it creates sometimes an enormous amount of heat. And when that happens, the blade can actually disform. So it can get like this. And you'll see it kind of going in there like this. If you see that, you stop now. Change the blade. It's too dull, it's too hot. The manufacturers of the blades put these notches in the blades right here. Let's take a closer look. These notches serve a couple of purposes. One, to cool the blade. So as the blade leaves the area of the wood and is rotating around the saw, it can pick up air and cool the surface of the blade. The second thing that it does is it helps to prevent the blade from becoming a wobble blade as it heats up. It gives this metal somewhere to expand. Anytime metal heats up, there is a certain amount of expansion that takes place. And in a saw blade, that has to be controlled, or every saw blade would just start wobbling as it heated up. And that is part of the heat control, or that expansion control that this metal experiences as it heats up cutting wood. So that's just another way to help prevent your table saw from kicking back: a sharp blade. Always make sure the blade is sharp. I know sometimes, because I've done it myself, I can finish the job with this blade. I don't have a new blade. I don't want to quit what I'm doing, run to Home Depot and get one, but guess what? I don't want to go to the emergency room either. So turn your saw off, get in your truck, and go get a blade. It will save you more than you'll ever know. The next thing that can cause kickback is a misaligned fence. When your fence is locked into position, it needs to be perfectly parallel to your blade. There's a couple different methods to check to make sure that your fence is perfectly parallel to your blade. Let's explain how kickback occurs if it isn't. So what can happen is your fence may be slightly crooked. Mine won't really push crooked, so I'm going to use this piece of wood to demonstrate. And this might be a little overkill, but let's say that your fence is crooked. And I'm talking just a 1/16 of an inch is all it takes. It's not much. As you're feeding the wood through, when you get to the fence that's over here and it's crooked, it starts binding the piece that you're cutting off. Because it's cut, so the kerf is open. When it gets to here, it's just pushing it into the back side of the blade. The back side of the blade has the potential to grab it and throw it out. This is not a good case scenario. You want to make absolutely sure that your fence is parallel to your blade. Go to my channel, go to my playlist, look under Table Saw Series, and you're going to find a complete video of how to tune up your table saw. There's a couple of tools that you can buy to make life easier. It's cheaper than a trip to the emergency room. I can tell you that personally, and I wish I would have bought them a long time ago instead of after I got hurt. So guys, buy those tools. Check your fence. Make sure that your blade is not only parallel to the miter slot, but that your fence is parallel to the miter slot. We're not actually checking to see that the fence is parallel to the blade. That is a good thing, and that will keep you safe, but that doesn't mean that you're cutting true. The miter slot is straight, so you want your fence perfectly straight with your miter slot and your blade perfectly straight with your miter slot. Now there's adjustments down here on my saw and on every table saw to be able to move this blade a little bit like this so that you can perfectly straighten it to the miter slot. The miter slot is the important key. It is what is straight, and if you align both the blade and the fence to the miter slot, you are going to reduce your chances of experiencing kickback greatly. If your table saw is brand new out of the box, you also need to perform these checks. You need to make sure that the blade is parallel to the fence, or that they're both parallel to the miter slot. Another way that we can prevent kickback is how we push the material through the saw. You want to push the material through the saw as squarely with the blade as possible. You would not want to put your push block over here, or try to cause this board to twist as you're pushing it. That wouldn't be good. Nor do you want to push it all the way on this corner, where you may actually cause the board to do this as you're pushing it through the saw. So the more square you can put your push block with the blade, the better off you are, the safer that cut is going to be. Always make sure you push the board straight through, and that your push block, your push sticks, whatever you're pushing this board with, even your hands, are controlling the board, keeping it tight to the fence so that none of this stuff is going on. For those of you who may be using your miter gauge to do cross cuts, I just want to point out that this is a horribly bad idea and is almost a 100% guarantee that you are going to experience kickback. Never, ever, under any circumstance, use your fence as a stop for the length of your cut off board. Once this board gets cut off and it gets into this area of the blade, it is going to twist and it is going to fly out of the saw at a rapid rate of speed. Never do that. Here's what you can do though. You can use your fence as a stop, but you need to take a small piece of material and clamp it to your fence with a bar clamp. Set your fence at the distance that you need for your piece, and as you push through, when it's clamped, obviously, that is going to stay behind. You will now be holding the board in place as you cut it to the correct length. That is a perfectly safe cut. So you can use the fence as a length stop for the pieces that you're cutting. If you're cutting multiple pieces of the same length, this is a perfectly safe way to do it. But do not butt it against the fence. Always make sure that there is some room between the fence and the cutoff piece, and you'll be perfectly safe. The things that we just covered, guys, are the most important. Say guys and gals, because I know there's some ladies watching too. So the next thing that we can do to help prevent kickback is featherboards. Now, featherboards are not 100% guaranteed. If your fence is crooked, if your blade is dull, if you're not running your riving knife or your riving knife is misadjusted, those are the 3 key things to prevent kickback. The nice thing about featherboards is they apply the down pressure that you need to keep the board tight to the table. They apply the in pressure that you need to keep the board tight to the fence. Now here's what I can say about featherboards. If you're using featherboards, and yes, mine are homemade, you can buy them if you want. I prefer to make mine. When they break or whatever, I throw them out and I buy new ones, you know, like this. One of these teeth is already given up, but it'll be all right. So when you're using featherboards and you experience kickback, it is going to greatly slow down what is happening, because now this board has to get these out of the way. So I'm going to lower this blade down and I'm going to show you how easily this board will advance forward through the blade, but yet how ridiculously impossible it is to pull it backwards. With literally one finger, I'm going to advance the blade forward, and you can see how easy it moves. Now, let's try pulling it back out of the saw. All right. I could just about probably pull my saw right over. I mean, I literally am. I could tip my saw over. So that's what I mean about it slowing them down. You can see how the teeth are trying to bend backwards. You can see how this one is bent pretty good backwards. It's a little thinner finger. And when a table saw kicks back, it happens so ridiculously fast. Guys, a piece of 2x4 flew out of my table saw and I didn't even see it. It went by so fast, my eyes didn't even see it go by. And what happened was, it hit my ceiling right there. It hit my cabinet door right here. I have no idea what else it hit, where it flew. It was crazy. The craziest thing that I've ever experienced. I just want to add that the sacrificial fence that I have my featherboard clamped to, this featherboard, everything are videos that I have on YouTube under Table Saw Series, guys. Look them up. Stay safe. Man, if I could keep one person out of the emergency room, that would be amazing. So when I say, guys, that wood left this saw at a rate that just blew me away, I kind of want to explain why that is. So this blade is spinning at approximately 3,000 RPM as you're using the saw. Depending on the workload, the bog on the motor, how strong your motor is, that may slow down to like 28, but it doesn't slow down a whole bunch. This line right here that I've drawn on this tooth, in case you don't understand RPMs, is revolutions per minute. So this particular carbide and any of these carbides are going to make 3,000 full rotations in a minute's time. Guys, that's moving. And when anything is rotating like that, it's creating kinetic energy. Kinetic energy is the force of energy to keep this thing rotating. Now the motor has some brakes and some other stuff when you turn it off, but if it's not turned off, it has that momentum, the kinetic energy, to just try to keep going. And that is why it throws it out so fast. The very last thing I want to talk about, guys and gals, never ever try to freehand push a board through your table saw. This is just a crazy thought process. Now believe me, I have been around table saws for a long time, and I know a lot of people that also have. And I've seen some people do some crazy stuff with their table saw and never experience kickback. I've also seen the exact opposite, where people did everything they could to be safe and they have experienced some form of kickback. Never people try to push anything freehand through this table saw without fencing it, without anything supporting the edge of this workpiece. Now that truly covers what you can do to prevent table saw kickback, but I do want to talk about a couple other things that can help to keep you safe if you do experience kickback. And the first one of them is going to be to keep the cutting surface of your table clean. Don't take your little cut-offs and stack them over here. Don't do anything like that. Don't keep this area of your saw clean. Anything this side of the fence, feel free to put your push sticks, your push block, anything else that you may be using. My saw has a nice little handle down here. It's got a couple of different places I can set stuff as I cut it, or I'll just drop it on the floor, dependent on what it is. I mean, if I'm cutting some filler strips for cabinets and they're red oak or something like that, obviously I'm not going to drop them on the floor. I'm going to turn the saw off, I'm going to walk away, I'm going to set them where they need to be. Keep your table clean. The next thing, guys, is your stance. Never ever stand directly behind this blade when you're pushing your workpiece through. You either want to be over here to this side of the saw, and it may seem funny to stand here, but it's not. I find myself on this side of my saw a whole lot more than I find myself on this side of the saw. But sometimes I do, if I'm not running feather boards or anything like that, and I want to keep an eye on this material staying in contact with this fence, then I am going to stand on this side so that I can see that better. Secondly, guys, push sticks. Make your own push sticks, buy push sticks, make some different thicknesses so that you can cut the thickness of material that you need to cut, whether it be 1/4 inch plywood, 1/2 inch plywood. You can make push sticks out of anything, and you want to have a couple of them so that you can hold the material tight to the fence and push it with the other push stick. The reason for this is if you experience kickback, like I said earlier, the momentum of this leaving and the forces of you pushing it forward is what actually puts your hand in the blade itself. So if you have this much extra room, chances are good, if kickback did occur, you could get your hand out of the way in time. Also, if you're standing over here to the side and kickback occurs, chances are good that board's going this way. You don't want this board to come up and hit you in the face, hit you in the chest. It is going to hurt. Secondly, guys, push blocks. Push blocks are very important. Push blocks are disposable. They're intended for your saw blade to cut through them. And when you're cutting through these, when it's all wore out, you just throw this part away, keep the handle, make a new one. So like I say, guys, push sticks, push blocks, feather board, sacrificial fence, all on my channel, all under the table saw series. Go to them, stay safe. Alright guys, that's all we got for this time. I hope that this video would give you the confidence, the courage, and the know-how to either purchase that table saw that you've always wanted to get, to use the table saw that you've just gotten safely, or for you guys that have been using table saws for years like me, the common sense to go out in the shop and check your stuff and make sure that you don't get hurt. Guys, always respect the power of your power tools. If you enjoyed yourself, click on one of these two videos. It's going to pop up right here, and we'll see you soon.